Hi. Let's see an end-to-end project which is done for a customer segmentation project. So this is an unsupervised machine learning problem. So which I've solved using k-means clustering. Okay. So just let me walk through to the project. So this was a like a RFM segmentation project, and which I solved using k-means clustering. So now let's see what is an RFM stands for. So RFM is a pretty known or industry standard based of customer segmentation, which uh, which is useful for most of the business use cases. So the in RFM, the R stands for recency. That is how recent the customer had made the purchase, and frequency, F stands for frequency. So that is nothing but how often the customer is doing the transaction. And when it comes to the M, so it is nothing but monetary. So that is how much money did the customer spend during a given duration, within a year or within a month. So that is nothing but monetary. So, so this RFM analysis will help the businesses to segment the customers, and based on multiple things, maybe for and mainly using for marketing, sales, and all those sort of things. Okay, so the project which demanding is to we need to segment our customers to help the marketing department to give a personalized offer or rewards based on the customer segments. So therefore, we can save our time as well as money for marketing, and also the customers can also get the benefit out of it. Okay, so this was the major aim by solving this project. Okay, so just see what is the data will look like. So it is around eight columns. So invoice number, customer story, stock code, description of the product, and what is the quantity, and invoice date, unit price, customer ID, and country. Okay, and since it's a unsupervised machine learning problem, so there is no target column, and so it was around 5.4 lakh records, and so there is few missing values. It was around 1.4 lakh records is missing, that is around 3.1 percentage of the total data, and there are some duplicate records as well. It's coming close to 1 percentage of the total data, and so there are some categorical columns, few numerical, and one data time. So invoice date is nothing but a date time format, and so this is pretty about the data, and I have done a detailed EDA, exploratory data analysis, on each of the column, which I mentioned with the graph, as well as whatever the finding which I mentioned in the bullet points. Okay, so once after done my EDA, so I just finalized what is the feature engineering steps which I need to do. So in the column, sorry, in the data, so most of the records are almost I can say 91 percentage um, country. So 91 percentage data belongs to United Kingdom. Okay, so you can see here 91.4 percentage of the data is coming in UK only. So I'm removing rest all the columns. I'm dropping it, and so in quantity column and unit price columns, so there were negative values. So usually quantity and unit price doesn't have negative values, so I'm dropping that as well, and I'm creating one new column called the total price by multiplying quantity and unit price. So the final data after this dropping and removal of records will look like this. So I'm just added this new column total price. So only keeping UK country only for the records. Okay. So just to create an RMF table, so that is recency, frequency, and monetary column. So we need a current date. So we are calculating all the things based on the current date. So I'm taking current date as 10/12/2011. Okay, and calculating the recency and okay, for calculating recency, we need the current date. And first time, what I'm doing is in order to produce this RMF table, I'm grouping the data based on customer ID. Okay, and based on all the customer ID, I'm creating RMF. Okay, so I'm grouping based on customer ID. Then I'm calculating recency by my create by using this formula, that is current date minus recent invoice date. So per customer. Okay, and frequency also I'm calculating based on some of the invoices per customer group, and monetary also I'm getting calculated by based on sum of the total price. So it will be like this. So final RMF column will look like this. So this is the equation which I've done. First I'm grouping it by customer ID, then applying for RMF, sorry, recency I'm applying on invoice date, current date minus X max. That is nothing but this previous data column, this max of customer, invoice date of what was a recent purchase, that will be X max, and it will be calculated for each customers. Similarly for a frequency as well as for monitoring. Okay, so this is the final data frame which I'm getting, and I just need to so this will be like invoice date. The column names are a little bit different, so I'm just mapping into like recency, frequency, and monetary. So this will be the final RMF table. Okay, so this will be customer ID, which I made it in index. So let's see the distribution of our recency, frequency, and monetary. So this will be look like this. And so there are few outliers in recency and few frequent. There is many outliers in frequency and monetary, and you can also see there is a skewed distribution. So this is also skewed, but outliers are very less comparing to these two. Okay, so just need to handle this skewness as well as the outliers. So what I'm doing is I'm applying multiple transformations and imputation methods. So what I'm doing is first I'm trying to drop all the outliers based on interquartile range, and calculating the what is the minimum value and maximum value by using the formula, that is 25 percentile plus 1.5 into IQR, and for the maximum value would be 75th percentile uh, plus 1.5 into IQR. When I applied it, and when I applied multiple transformations, so I'm using log transformation, square root transformation, cube root, Yo Johnson, and box Cox. Okay, I'm applying for all three: recency, frequency, and monitoring. Since monetary reason, sorry, uh, monetary was having some negative values and some zero values. So because of that, Yo Johnson was giving some error. So I just only put the graph for recency and frequency, not for monetary. Okay, so I'm simultaneously applying transformation as well as the player removal. Okay, for all these columns. Similarly, I'm also trying to do a removal of outliers based on 1 percentile and 99 percentile. So this looks better than 95 to 5 percentile, because when I'm using 5th percentile and 95th percentiles, it almost removed 29 percentile of the data. Okay, and so this is also not that good when coming to the other strategies which I have used. So what I'm doing is one more thing. So whatever the minimum and maximum which I calculated, I'm trying to impute that with outlier. First, I'm like trying to make like all outliers as nan, then imputing with minimum, or else with maximum value. Then I'm doing the transformation. So you can see like I'm getting there is a frequency or the count increase at the positive tail end. So this is also not that good transformation and outlier handling, and so that is nothing but capping. So I've finally finalized on KNN imputer, and I used the same multiple transformations. So Johnson and Boxcox was giving me better results. So I finalized with KNN in order to outlier handling, and Yo Johnson to handle the skewness, as well as it does the standardization of the data as well. So this will be the final data will look like after handling the outliers as well as the skewness. So with this data, I'm trying to do the segmentation using k-means algorithm. So in order to find the optimal number of clusters, I'm using an elbow plot. So what I'm doing is like I'm trying to fit multiple k-means, and by giving multiple k values, and for all the k is nothing but the number of clusters. So at multiple number of clusters, I'm trying to find the WCSS, that is within cluster squared sum error. Squared sum. Okay. So with that, I'm doing the like elbow plot, and so this is the first method. So I used an automated method which is available with the neat library with a knee locator. So this will give you the optimal number of clusters which is needed for k-means without plotting this elbow plot. So this also given me a cluster value as 4. So with this, I created a final model, and I done the prediction. And whatever the prediction done with the k-means final k-mean model, I'm appending with the data frame. So this will be the clusters. So clusters will be like 0, 1, 2, 3. So 4 clusters. Okay. So when I visualize the clusters, so this is how it look like. So there is purple, yellow, light orange, and blue. So we can see like this purple is a good set of customers which have good frequency, and the recency is also like uh, almost close to or within 50, I will say, and monetary is also like good comparing to our other clusters. And when it comes to that yellow cluster, so this will be like a good set of customer, and yellow will be like a going to churn customer. So they were loyal, but now it's like almost going to be churn, since the recency is getting increased, or recency is very bad for these, even though the frequency as well as monetary is good. And the light orange, this set of customers are all churned customers. So there is recency is very high, and frequency is also not that good, and monetary is also very less. And for blue, so this will be like a new customers which just started purchasing or using the like company services. So the blue comes over here. So there all the values are very less. So recency is good, monetary is not that good, and frequency is also, I will say, a good comparing to other two clusters. Okay. And for deployment purposes, what I'm doing is like just making a new data frame with customer ID and type of customers. So I'm creating four set of customers, that is loyal customers, about to churn, churned customer, and a new customer. So based on these cluster colors or the num cluster number, I'm mapping it to mapping these cluster values into a human readable or understandable uh, names. Okay, and finally I've deployed the data into Heroku, and if I see the deployment, so let's see so this is deployed to Heroku. So let's see how the prediction will look like. So it is a loyal customer. And if I can give a customer ID which is maybe 43. So customer ID is not found in database, maybe a new customer, or please check the customer ID. Okay, so for other customer, it's predicting new customer. And if I go to another um, customer ID, so this will be a churn customer, and so this will be like a about to churn customers. So the model prediction is also happening based on the data which we are deployed. So this is like a simple UI which a marketing or a marketing person which you can use, and so based on the customer ID we can predict so that customer belongs to which segment. So accordingly they can give whatever the rewards or any other promo codes or any coupons which they can give to attract the customer or to make it as a loyal customer. Yeah, thank you.